それではですね、先にちょっとご紹介をしたいと思います。次のテーマはですね、アルファウェーブセミの高性能コネクティビティ IP と、チップ統合技術ということで、スーホンさん、この方はですね、アルファウェーブセミの、IP 事業部プロダクトラインマネージャーでいらっしゃいます。
But yeah, thank you for having me, everyone there in Tokyo. I am filling in today for Jennifer Lee at Alphawave Semi. She's asked me to do this last minute, so I want to introduce myself. I'm Fung, and I'm the PLM or product line manager for chiplets here at Alphawave Semi. I'm going to introduce some information about Alphawave Semi and then share how we're accelerating time to market through some of our chiplet reference architectures, and also those are built on our high performance connectivity IP. So I'll give you a brief overview and then walk through our IP portfolio, where we fit in the system with chiplets, and then wrap up with a summary. Feel free to, ask me any questions, as long as they're not some sensitive topics about the company structure and upcoming news. But yeah, I'm okay to answer some things. So here's some information about Alphawave Semi. We were founded back in 2017, and we've actually grown into this global presence worldwide with offices in Canada. We're in the Silicon Valley Bay Area. That's where I'm located. We're also in London, Tel Aviv. We have a couple offices in India. We're in Taipei and Shanghai as well. So we are a semiconductor provider of connectivity IP. We also have chiplets, custom silicon, as well as optical DSP products. We have grown into a worldwide headcount of more than 1,200 plus employees, and our target applications are on the lower right-hand side, but where we intend to be big major players is in the data centers for AI and ML. Some of the foundries that we are partnering with are leading foundries across a wide range of process nodes, and by doing that, we're giving our customers a lot of flexibility in technology choice to ensure that the IPs and the chiplet solutions that we provide can be manufactured where and how they need them to be. So here's some of our IP and chiplet solution offerings. We do have multi-protocol 112 gig SerDes, and that is multi-protocol because it can use PCIe, CXL, and Ethernet. Our 224 gig SerDes architecture is also multi-protocol and can support UA-Link, the latest Ultra Ethernet, as well as the 802.3 DJ Ethernet spec. We do have high bandwidth memory, HBM, that's targeted for accelerators and compute in the data centers. And then we have UCIe, which we employ on all the chiplets for die-to-die connectivity. And we are offering fine controller solutions across all of our IP offerings that can then be used for integration into ASICs or chiplet architectures. And then also looking ahead, we're advancing towards next generation technologies and packaging to include 3D hybrid bonding. And that's going to enable even higher bandwidth and integration density, because those pitches for 3D hybrid bonding are going to be 9 microns and below. And the data rates are not going up for hybrid bonding UCIe, but coming down to 4 gig plus. And even though that is coming down, you still get the higher bandwidth density with the tighter pitches of 9 and below. So if you've been following us, you might have seen some of our recent demos at Supercompute in St. Louis, or ECOC over in Europe, where we were showing our PCIe over optics. We've been demoing our 224 gig SerDes, and we've also been showing our chiplet solutions over copper and optics, and also we recently showed that over immersion cooling. We are also integrating RISC-V microcontrollers across our ASICs and chiplet platforms, and that helps to manage the key functions such as power and clock control, telemetry monitoring, as well as secure boot. And that allows us to keep our system management efficient and flexible. Okay, so why is Alphawave Semi's technology so relevant for modern data centers? If you look at where AI is going today, models like ChatGPT, they're already running on tens of billions of parameters. And now we're moving rapidly towards the trillion parameter era. And we're moving these models to scale with a lot of data that needs to move through the data center. And that data is just growing exponentially. And it's not just more compute, but it's more bandwidth. It's a lot lower latency requirements to enable all of that data movement. So that's where Alphawave Semi comes in. We have our connectivity IP and chiplet solutions. They're built for the next generation compute CPUs, accelerator GPUs, and where the interconnect performance can become a bottleneck if you can't scale this fast enough. And we're enabling that bandwidth to have memory access for, die-to-die communication between chiplets to keep up with that exponential growth in data. And today our solution is valuable because connectivity in the data center is one of the hardest challenges for AI. We are supporting a wide range of applications with easy to integrate IPs. We balance out that cost and performance with provided silicon, known good dies, and we provide IPs and leading edge process nodes with multiple strong foundry partnerships. So our IPs are silicon proven before those are put into ASICs and chiplets to feed that demand, and that in turn means lower time to market and savings on development time with the pre-verified IP and chiplet connectivity solutions. So here's a system overview for supporting data center scale up and scale out with our IPs as well as our chiplet solutions. We can scale out off the rack by leveraging Ethernet or the Ultra Ethernet spec for front and back end networking. And then we can scale up within the rack by using PCIe or UA-Link connections. And we're enabling memory pooling with CXL. Our high bandwidth memory can be utilized for accelerators or XPUs. And then we're employing UCIe across all of the chiplets, which is for die-to-die chiplet interconnect in open standard. So just a slide here about, or a couple slides on UCIe. It is serving as, a low power and low latency connectivity between chiplets. So for compute to compute connections, you can connect a CPU chiplet to an accelerator GPU chiplet and then with Chi C2C employed on UCIe, you can enable cache coherency across the die so that your accelerator can access the compute memory. And then for compute to memory applications, UCIe streaming can be implemented on custom HBM4 solutions. And then for optical I/O chiplets, we can take UCIe and reconfigure that into retimer mode. There's a retimer mode in the spec, and that directly drives optical interfaces. So we provide the PHY and controller for UCIe, and those building blocks are available across multiple technologies and foundries from 7 nanometers down to 2 nanometer. And we're going up to 64 gig, which is the latest 3.0 spec. And we have compatible packaging solutions on all different types. 2D for organic substrate, 2.5D for interposer, bridge, and RDL, as well as 3D hybrid bonding that I had mentioned before. Just a little bit more about UCIe. We do have UCIe across 3 generations. The first generation that we provided was 24 gig, and then moving up to 36 gig, and the latest is 64 gig with the latest UCIe spec. And we are actively taping out a UCIe with 3D hybrid bonding. Our test chips support both standard and advanced packages for 2 and 2.5D integration. So we collaborate actually with multiple foundries and OSATs to provide a lot of packaging flexibility for our customers, and our packaging team has a lot of expertise that helps our customers with custom ASICs or chiplets. And then we also always employ full DFT on there. UCIe has BIS testing on there, so that means that we can ensure that we have KGDs, known good dies. It has per lane health monitoring. That means that you're going to be ensuring that you have robust wide data eyes during mission mode. And all these designs are fully compliant with the latest UCIe specs. So with more of our IPs that go into chiplets, we have PCIe, where we're enabling connections from the compute to an accelerator XPU through up to Gen 7. So if you were to use PCIe, that would mean chip-to-chip connection versus the UCIe would be die-to-die. But and both of those can have Chi C2C to enable that cache coherency. CXL provides access for memory pooling, and then we can scale up within the rack using the UA link to a UA link switch. For off-rack scaling, we can leverage Ultra Ethernet, and then the 802.3 DJ spec. For Ethernet, it can be used on the back end in data centers, and it's also fully supported in UEC or Ultra Ethernet. So we are accelerating time to market with our IPs for next generation XPUs. We support a very flexible engagement model, meaning that we can provide IPs, chiplets, and custom designs. And we provide the test chip solutions for Fung controller across all of these, the Gen 6, Gen 7, 224 gig SerDes, and we validate that silicon functionality before any integration into chiplets or ASICs. So here's the different ways that you can use and integrate our solutions. We can provide an IP-only model, meaning that these IPs are pre-validated, silicon-proven subsystems of the fine controller, and then the customers can take that IP, integrate it into their design, and then go take their design to tape out at the foundry. Then we also provide foundational I/O chiplets. That means that customers can leverage our standard chiplets or our die silicon, which can be provided as known good dies. So that's all designed in, and the silicon is provided. Or custom chiplets, where we would support fully custom designs, or even an adaptation of our chiplet reference design, where you can take our reference building blocks from our I/O chiplet and then add some, lanes, or change the package type, or add some different protocols. And that would be a custom chiplet or a custom design where we can provide known good dies and enable any level of customization, including our packaging support for 2.5D and 3D integration. So this is the summary and final slide. Alphawave Semi does provide scalable, interoperable AI data communication solutions, connecting compute, memory, and I/O. Our silicon-proven IPs and our chiplet building blocks will help to accelerate time to market for next-generation XPUs, and it supports very flexible engagement models, including custom ASIC and chiplet designs. And let me know if you have any questions. Thank you. I appreciate everyone's time.
Thank you very much, Ms. Hon.
Thank you.
Does anyone have any questions?
Hi, thank you very much. So very interesting presentation. Thank you. Do you hear me?
Yes, I can hear you.
Okay. So is my Japanese English okay for you?
Yes, that's good. It's
Okay.
good. Thank you.
So sorry, I'm still confused. What are you selling? Chiplet, IP, or something else? What is your main products? Chiplets?
Actually, all of the above. So we have the IPs that I covered. We also have a chiplet roadmap, and we do custom chiplets and ASICs. And we also have, as I mentioned in the beginning, DSPs. So we actually have a wide range of products which can go into data centers.
Okay, thank you.
You're welcome.
他にご質問ありますか?
Any other questions?
ご質問ありますか?
Okay. If there's no questions.
So I have one question for you.
Sure.
Your chiplet is focused on the server system, cloud server system chip. The next, I think, something security chiplet is required for those applications, I think. How do you think about secure chip, something like T or root of trust functionality on chiplet? How do you think?
So it did kind of break up. I did hear something about security. In our custom ASIC and chiplets, we do employ security or secure boot per the customer's requirements, and that could be using, something up to the customer. I'm not sure that I heard everything, but there are some open standards also that can be used.
Okay, thank you very much.
Sure.
So, so how much of a standardization have happened on chiplet interconnect and things? Can you hear me okay?
Yeah, you asked how much standardization
has happened. I mean, is it
chip interconnect?
Yeah, particularly in the area of interoperabilities. How
in the area of what? Sorry.
Interoperability. Sorry.
Yeah, interoperability. Yeah, so we are actually doing a lot of interoperability across multiple, with different partners on UCIe, and we've actually gone through, and some of these are public announcements, several companies we've done it, different process nodes, different foundries, and we've done that across the RDI interface, PHY to PHY, and also with the way that UCIe actually defines the protocol level, the UCIe streaming today is not something that is very interoperable. It is vendor specific. So UCIe streaming has that limitation, but UCIe does have controllers over PCIe or controllers over CXL, and those, as defined in the UCIe spec, are interoperable, so up to the FDI level. So we are actually working with other partners on that as well. We do a large range of interop with UCIe. But that is a very often asked question, and I think that's a big question, that comes up a lot, and ways that this can be further standardized.
Okay, thank you. One more question. How does your IP relate to optical connectivities?
Yeah, so that's a really good question. So we have, we have the chiplet. It's the Alpha Chip 1600 IO, and we've been showing that with optical connectivity using QSFP or OSFP, and then using optical transceiver modules with LPO, LRO, fully retimed. So we've been showing that, and then we also have that with NPO right now. So we've actually just demoed that on NPO, near packaged optics. So the optical module is directly on the board near the SerDes. And then we're actually working towards CPO as well, co-packaged optics. So we are, showing a lot of optical connectivity there. And we've also partnered with many different partners to work towards the next CPO.
Thank you very much.
Sure.
That's a lot of information.
Okay, good. I'm glad.
Thank you very much, Ms. Hong. So time is coming. So everyone, please give her a round of applause. 拍手お願いします。
Thank you.
Thank you very much.
Thank you. Okay. Goodbye, everybody.
Thank you.